This is passage 6. It's a data passage on 67C. Our DRC approach, D is data. That means don't read. Just spend a bit of time orienting yourself to the passage, to the questions in 20 to 30 seconds. Now, do be aware this passage has steps, steps 1 to 6. That means they're probably going to ask a question about the procedure. Besides that, just look at the X and Y axis, know what you're dealing with, and where to look. Figure 1, figure 2, maybe what's the difference in the two. Looks like it's just a size 3-liter vessel versus a 6-liter vessel. Maybe skim the steps in the procedure, but still, to the questions very quickly. Don't spend a lot of time trying to understand what's going on. Our approach to the questions is the R and R approach. So you're going to read the question and then reread the question. So in your first reading, you're just trying to understand what it's asking, kind of orienting yourself, skimming, if you will. And then your reread, you're really breaking it down step by step. So as we go through it, I'm going to be doing the reread part. Already read it. Hopefully you've already read it and we're rereading. If you haven't read it before we start, pause the video and read it before we start. Number 31, based on figure 2, so put your finger on figure 2. If, this is an if, suppose, why question, means you're going to have to think, add something to it. So 13 grams of KR, I'm not sure what KR is. So 13 grams, we're going to have to extend how far this goes. You could actually use your answer document or pencil as kind of a measuring device and see about how far it would be. So it looks to me like it's 12 and a little bit more. So that's kind of guesstimated about where it's going to be. So if 13 grams has been added to the 6-liter vessel, so make sure the 6-liter vessel, the pressure would have been what? So there's the pressure. So it would have been a little over 400. So between 400 and 600. See? Question 32 is another suppose if why question. It means you're going to have to think. The experiments had been repeated except with a 5-liter vessel based on figures 1 and 2. So using both figures. The pressure exerted by 7 grams, I guess that's what the G is, of CO2. So we're using the CO2 would most likely have been. So 5 liters is between. So you're going to have to, again, think, extrapolate some data from it. So if at 7 grams of CO2 in the 3, it's at about, I guess it's 900. And at 7 grams in the 6-liter vessel, it looks like about 500. So between 500 and 900, or G. Number 33, based on figures 1 and 2, put your finger on figures 1 and 2, for a given mass of O2, so that's here, at 22 degrees Celsius, which just says it's the same as explained in the text, how does the pressure exerted by O2 in the 6-liter vessel compare with the pressure exerted by the O2 vessel? In the 6-liter vessel, the pressure will be. So we're going to say the 6-liter vessel is. So let's just pick a spot to compare. I'm going to pick the 4. And on the 6-liter vessel, the 4 is 400. The 3-liter vessel, the 4 mass of 4 is 800. So the pressure will be, it looks like half. Let's double check. So 6-liter at 6 is 600. And 1200 in the 4, so we put that on the table if it helps you to see it better. The pressure in the 6-liter is half as much as the pressure in the 3-liter, so your answer is A. Which of the following best explains why equal masses of O2 and CO2 at the same temperature and the same size vessel had different pressures? The pressure exerted by O2 was, okay, so we can eliminate choice F and G because if we look at the pressure of O2 versus CO2, we can see in the chart that O2 is at a higher pressure than CO2 at any given point. So we know that F and G are wrong. Even if you don't understand why, you can see in the chart that they're wrong. Now the next part does require some knowledge. Is the pressure on O2 greater because there were fewer molecules or more molecules? And this is just a basic science knowledge, so it would be greater because there were more molecules. Just think about even stuffing people into a room. the more people in the room, the more pressure there seems to be in the room. So J. It's a suppose question again, so you're going to have to think. Suppose the experiment involving O2 in a 6-liter vessel have been repeated except at a room temperature of 14. So the original experiment measured the temperature at 22 degrees Celsius. For a given mass of O2, compared to the pressure measured in the original experiment, the pressure at 14 would have been. So this is a knowledge question. Is pressure greater at 22 or 14? So at 14, the pressure is it less or greater? So you have to know that as temperature goes up, pressure goes up. Just think about boiling water with a top on it. When the water boils, the temperature heats up, right? And so the top starts to vibrate and can even pop off, explode if there's enough pressure. So we can eliminate C and D. And then what we have to say, is it directly proportional or inversely proportional? Directly means as one thing goes up, the other goes up. So as temperature goes up, pressure goes up. So the answer would be A. So some knowledge involved in that question. Remember, 1 to 5 questions on the test will have some form of scientific knowledge needed to answer the question.